MDM4U 7.2 binomial distributions. A binomial random variable has the following characteristics. An experiment is being conducted with a set number of trials. The outcome of each trial is either a success or failure. Trials are independent, so the chances of success and failure are the same in each trial. When this criteria is met, we can use this formula, the probability of a particular outcome. So say, for example, we were interested in the likelihood that exactly 3 out of the total number of trials was successful. This formula will help us calculate this, where P represents the probability of success, Q represents the probability of failure, N is the total number of trials, and X is the particular outcome that we are interested in observing. Maybe it's 2 successes or 3 successes. When a situation has the characteristics described above, we can use this version of the expected value formula to calculate the expected value. What we would expect to happen if this probability experiment were to occur. N is the number of trials total, and P is the probability of success. So we've seen probability problems in the past where we're interested in a particular outcome, and we can calculate the likelihood. Say a die is rolled 10 times. What is the probability that you will roll a 6 exactly 3 times within those 10 trials? So using the guess method, the given information is recorded from the question. The unknown component, though, is what is the likelihood of getting 3 6s rolled in 10 trials? So we can substitute in for the value of x equals 3 into this formula. And notice that we have 3 successes. 10 minus 3 is 7. So 3 plus 7 is equal to 10 total trials. And the order in which success and failure occur are up to chance. There's many ways in which it can occur. In fact, if we were to have 10 trials and we were to select 3 of them, that would be 10 choose 3 ways that we could have success and failure occurring. So this helps account for all the different orders that are possible in order to have 3 successes and 7 failures. Try to calculate this value and see that you're able to get that result. Next, for this exact situation, if there are 10 trials, we would have a probability of 1/6. The expected value formula in this context is 10 times 1/6, which is approximately 1.6. So what we're going to do is look at what makes this a probability distribution. If we were to look at a situation where we have a set number of trials, 10, the number of times a 6 is recorded, the number of times 6 is rolled is recorded, we could have anywhere from 0 to 10 6s rolled in 10 trials. It's possible. So this calculation will help us determine the likelihood of each of these different outcomes. This is a probability distribution table, and this is a probability distribution graph. So the advantage of probability distributions is that you're able to see the likelihood of each and every single outcome in comparison to one another. So we could have 0 occurrences of rolling a 6 in 10 trials. It's not very likely, but it's possible to have 10 out of 10 trials rolling a 6, and we can see the distribution.